Okay, today is part review for the vectors test and part introduction to the lab. So in the lab, it's about vectors, of course. There's a vector for the bowling ball because the bowling ball will have what and what? Direction and magnitude. And the direction it'll be rolling is right down the commons. Okay, so this whole thing, you could call it bowling ball lab. Don't forget, you need the title at the top or you're not going to get credit for that on your sketch. Then, underneath, this is the spot 0, 0. That's where you start. And that bowling ball rolls and it'll stay right on a line. You know, you can see the lines on the floor of this room. It'll stay right on a nice straight line and you'll see it'll roll straight as an arrow. And that part works really nice. Can you start the vector equation for that? You should be able to, because you know the starting point. And you know how all vector equations look to start with. You know they all have a t or a lambda. In this case, I would recommend you use lambda. And then I want you to think for a second. Do you get the speed? The speed of the bowling ball is related to what number we would put into the equation. Oop, not lambda, sorry. No, not t, use lambda. Do you get that this somehow is related to the speed of the bowling ball? Okay. Do you agree it only moves in the x direction? Think about it. Is that bowling ball ever going to, like, all of a sudden go up? No, it's going to stay x. It's just x. So there's, what else could you tell me about that vector? Then, if there's two numbers, one of them's here, one of them's here, one of them you know. What is it? 0 for the what? For the what? Okay, so the bottom one is a 0. So then you just got to figure out that number. How are you going to know what that number is? Let's say I roll a bowling ball. And let's say that the bowling ball goes 2 meters per second. It would not be a 2. Why? If I put a 2 in, think about this for a second. I get that you might think that would be a 2, but do you get if you put a 2 here, the speed would be the square root of 2? Know what I mean? So if you knew the speed was going to be 4, if we knew the speed was going to be 2, we wouldn't put a 2 there. We'd put a 4 there, wouldn't we? All right, so then we just need to know what the speed is, and whatever the speed is, we're not going to put that number right there. Or are we? Let's say that the speed was 2 meters per second. Where should the ball be at 2 seconds? It should be at 4. Then what number should go there? So what is going on? Should this be a 2? At 1 second, would you agree at 1 second, if the speed was 2, shouldn't this be at 2, 0? So then, isn't this the right answer for it? All right. Those are the kind of things you're going to have to think through. And then, how fast is the bowling ball going to be going? You'll be measuring it. You'll be taking a little timer, like your iPad or your watch or something, and you'll time it. You'll see it goes like 6 feet in 6 seconds. You'll be like, oh, it's 1 foot per second. Or meters or whatever. Okay, so we will figure out that speed by actually rolling the ball. Next. Excuse me. I'm going to leave this as a great start to your equation, and then from there, you got to figure out what goes there, and that's the simple equation. Remember, labs usually take a while. It's not like, oh, there it is, I'm done. All right, so what's the harder part? The harder part is writing the other equation for the other ball. Well, how about this? Where does the other ball start? It starts right here. Start for second ball. and you're going to roll that second ball at an angle, because if you were to roll that second ball like straight this way, because of the distances that they are apart, the balls would not hit. Do you get if you roll it at the right angle? We're not going to do this on purpose so you can't make it hit. We're going to make it so you can make them hit. So if you roll that ball at the right angle, not straight down, but more like this, if you roll it at the right angle, they will hit. All right, so then what do you need to know about the second ball? You need to know the speed of the second ball. Very good. And they are different speeds. That'd be a little too easy if they were the same exact speed. So then what speed is it? Well, again, I got two ramps. We'll roll a bowling ball. We'll measure it and see, oh, this one looks like it's going this fast. We'll try the other ramp. Roll that one. Measure the time and speed on that one and figure out, oh, second balls are going at this speed. We do need to know where the second ball starts. So let's start the equation. The second equation. What do you always have first when a vector equation? Always. Every single one has this. X, Y. Okay, and then what does it have next? Where it starts, and I'm not telling you yet, but that's where you'll put it. Let's say that it started at over 15 meters and up 5 meters. Then it'd be 15.5. It's not exactly that, though, so don't write that in there. You're going to think that that's what I told you. It's kind of in the neighborhood of 15 meters over and 5 meters up, but it's not 15.5. It's kind of close to that, though. Okay, so we'll need to tell you where that is, or you'd need to measure it. I think in this case, it's such a long distance. If you screw up that measurement, everything's going to be off. I'll probably give you that number. Plus, I'll have another vector equation, and this one should not use the same lambda. We should use t for this one. So let's squeeze a t in right here. And this is just a starting point. That's easy. And I told you, I'm going to even tell you that. So then where does all the work have to come from? That little one right there. If you can figure out what's in that little parenthesis, then you have colliding vectors. Do you get that we have done several? Here's two vectors. When do they collide? We've done several of those. So I'm going to pause for a second. Okay, so this one right here we're going to give you, and this one right here is the only one that's difficult. Once you've got this, you've got two vector equations. This one, which I know I haven't finished it, you have to do that, and this one, which again I'm going to give you some of it. You'll just have to see whether they collide. No, you're going to have to set them so they do collide. You're going to make sure that they collide. All right, so how about this last one? Do you get how I drew a triangle right here? And I said, don't roll it straight because it won't work. Do roll it at an angle because then it will work. And then what is the angle you have to roll it at? Well, do you think I'm going to tell you the angle? No, that's what you have to figure out. We're going to call the angle theta. And obviously, theta is in a right triangle. And so you know all kinds of things about it because it's in a right triangle. And you also know that this direction, that direction is exactly not y. Do you get how it's going in the exact opposite direction as y? This line right here, I'll just clarify which one I'm drawing on. I'll make it green this time. That one is not y. That's the opposite of y. And it goes in this direction xy, which is not x. It's the exact opposite of x, right? Okay, you're distracting. Okay, so sorry about the distraction there, but you'll have two vector equations, and you're not going to see if they collide. You're going to make it so that they do collide. And then, when you actually go out into the commons, you'll have your sets of equations, and the main thing you'll come in armed with is, what is that angle? Because if you know what angle to roll it at, you'll already know ahead of time how fast the different balls are going to go. All you got to do is set up the right angle and let the balls go. Hopefully they'll hit. But most groups don't hit on the first try. So just be aware, even with really good equations, then they don't hit on the first try. So you get, well, I gave 4 tries one year so that everybody could have the feeling of success. But at a minimum, I'm going to give you 3 tries to make the balls hit. So if you realize that, oh, we rolled them and dang it, this ball was like a little late, and if it had been a little faster, well, can you make the ball speed up? No. The only thing you're going to change is the angle. So then you're going to be able to tweak it, and I'm telling you, it's not as easy as you'd think. They're released at the same time, unless your group hits on the first try, and then I say, okay, I'm giving you a challenge. Readjust, and now we'll have a 1-second time delay. And you can refigure your equation and then try it again and see if you can get them to hit with a 1-second time delay. That would be pretty awesome. But that doesn't happen for many groups. Usually it's hard to make them hit. And one of the reasons is there's so many things in the real world that don't fit into our equations. Like, for example, the ball is rolling. Do you get that the ball is slowly slowing down? Now, it doesn't have that much time to slow down because the ball is only going to be rolling for literally like 1.5 seconds, maybe 2 seconds. Okay? So don't think, oh, it's going to be way off because of that. No, it will be a little bit off because of that, but not very much. But there's other things like, do you think the floor out there is perfectly level? No. Do you think the bowling balls are perfectly round? No. So do you get how there's all kinds of things that can throw you off? So don't be like, oh, mine didn't hit. I'm terrible at math. If you get them to be close, that means probably your equations were even right. It's just the real world threw you off a little bit. Actually do the balls? Oh, okay. So I'm going to, on not Monday, we're not going to be here Monday. On Tuesday, I'll have the bowling balls here in the room, and we will roll them and time them and see how fast they go. Does that make sense? All right. So I'll tell you, we'll be able to know the speeds pretty easily. If you roll it for 5 meters and it takes 5 seconds, then it'll be 5 meters per 5 seconds, 1 meter per second. It'll be something like that. Yes? Good question. I'm not picking groups until Tuesday, and I think I'm going to do like a deal where you're paired with somebody, and then the 2 of you will find 2 other people that are going to work together. So you'll have a partner, because what I don't want is for people that don't know anybody to be just like, oh, I have nobody. Okay, but I want you to have some say in it, so it'll be like a hybrid. You'll have somebody to work with, and then those 2 finds 2 other people to work with, and then maybe you'll have a little bit of say in it that way. We'll see. All right. So, I think that's all I want to say about that. I feel like Forrest Gump for a second there. All right, so that's the beginning. Get your subconscious processing. That has to do with the speed of the ball, that one ball. This has to do with the speed of the ball, but it also has to do with the angle of the ball. And this is just your starting spot. So that's going to be the challenging one. Some of you guys are going to be like, hey, that sounds like a challenge. I can figure that out. And you could. I told you everything. You could do it. All right, let's move on. Now, different problem, completely different. I'm going to give you a vector, 217. I'm going to say that that has a speed of 17. Tell me if I'm right or not. How do you know so quickly that I'm not right? Because the magnitude, which is what you're finding, right? And the magnitude and the speed are pretty much the same thing, right? And so what's the magnitude of this thing? Can you do it? You were just estimating in your head, right? Because you're going, that's 49, that's 4, that's 1. So it's square root of 54. And that is certainly not 18, is it? Okay. I'm guessing you were going to say the same thing. You were raising your hand, which I appreciate, but all right. So my question for you is this. If that's not going 18 meters per second, it's going square root of 54 meters per second, how could we make it go in the same direction, but force it to be going 18 meters per second? Yes? Yes. So everybody use a unit vector in case you forgot what that is. It's that little thing where we're going to scale this thing down to be a length of 1, as in a magnitude of 1, as in a speed of 1. And then scale it up after we've scaled it down to a speed of 1. You just have to multiply by 18. It will be going 18. All right, so go ahead and do that. And then here's the final question that would be like what we'd ask you. Make a vector equation that goes through 1, 2, 3 in the same direction as this one, but at 18 meters per second. So you're making a vector that goes through the point 1, 2, 3 and goes in the same direction as this one does, but this one would have had a speed of square root of 54, and that is not 18. Make it be. So your final answer is an equation. Your final answer is not just a vector. Final answer is an equation like this. Make an equation like that, except it needs to be going through the point 1, 2, 3. And I know some people are going to think that's the really hard part. It's not. How could you be sure a vector would go through 1, 2, 3? Start it there. Exactly. Then it'll go through it. Start it at 1, 2, 3. So you're making me an answer like this, but not this, because something's wrong with it. A lot of things are wrong with it, actually. All right, I'm going to pause for a second while you give that a try. All right, hopefully you figured out this is 1 over root 54. But wait, that would scale it down to being 1. Now we got to scale it up to being 18. So then we put a times by 18, but 1 times 18 is 18. There. There it is. But wait, that's not an equation. How could I make it an equation? I could move it over and give it a starting point and stuff. So I'm going to move this over. I'm going to get rid of this. And just slide that over a little bit. And then I'll squeeze in an x, y, z equals starting point 1, 2, 3 with a little plus t right here, or lambda would be fine. A lot of people, I bet, forgot to put a t or a lambda right there. Okay, that one's a little intense, but I think it's doable. As long as you understand the speed and magnitude, the same thing. Yes. Yes, you absolutely should multiply it all out. So that would give you a final answer of t would stay here. This 18 over root 54 could be multiplied in, and you get 36 over root 54, 18 over root 54, and whatever 7 times 18 over root 54 is. Yes. But honestly, even on the test, I might tell you to leave it because it's more clean and easier to grade if it's just like that. So we'll see. All right. So that's about unit vectors. What else do you have to know? Well, how about if I give you 2 points? 1, 2, 3, and 4, 5, 6. What is the vector that starts at 1, 2, 3 and goes to 4, 5, 6? And remember, it's not, these aren't the numbers that are in both of the parentheses. One of them is. So give me an equation that starts at 1, 2, 3 and goes to 4, 5, 6. I'll pause for a second. Let me give that a try. This one, you should have said, starts at 1, 2, 3. So that's x, y, z equals 1, 2, 3 plus t times, wait, how do I get these? You go 4 minus the 1 makes 3. 5 minus the 2 makes 3. 6 minus the 3 makes 3. There it is. All right. Next, would you tell me where it would be at time 5? Where would your vector be at time 5? I like to think of it this way. The vector at time 0 is where it starts. At time 1, it's after you put in the t equals 1 in your equation, it's at a point. So if you're looking at it as a physical arrow like I have in my hands here in classroom here, if I hold up this arrow, it starts here, and after time 1, it's here. After time 2, then I would need 2 rulers. After time 2, it's out there. At time -1, it would have been back there. Okay. All right. How about time 5? So I just slap a 5 in right here. And so this is 1 plus 15. And this is going to be 15 and 15, right? So 1 plus 15 is 16. 2 plus 15 is 17. 3 plus 15 is 18. Raise your hand if you had that point. Awesome. You would be at this point at time 5. All right. Next one we could do is the angle between. Another one we could do is make one perpendicular to this. Let's do that one next. Would you please make a vector that would run, actually first do parallel. I think you'll see parallel is super easy. Make me an equation parallel to that one. Hoping you'll find, oh come on, that's super easy. Parallel to that one. And just to clarify, not the same exact vector, because that wouldn't be parallel to it, it would be on top of it. What do you think, Lefty? Yep, because now it's kind of like the slope. If the slopes are the same, you know, the equations are parallel. It's kind of like the slope. All right. And all you needed was a different starting point, and yay, they're parallel. Now here's the harder one. This is not impossible by any means, but I'm going to give you a more challenging question. I need a vector that goes through 4, 9, -2 and is perpendicular. And see if you remember what the secret was to perpendicular vectors. Yeah, the vector that goes through 4, 9, -2 and is perpendicular to the above vector. Okay, I'm going to pause and try that one. All right, there's a hard way and an easy way to do the goes through 4, 9, -2. How many of you figured out you should just start with 4, 9, -2? Because then it goes through it. Okay, awesome. There's other ways. They'd be much more complicated. Then, how do I make this so that it's perpendicular to that? Its dot product needs to what? Equal 0. So could I just put 0, 0, 0? No, I'm not going to allow that on the test either, because that means that this isn't really moving. It's just a spot in space. And how can a spot in space be perpendicular to a vector? Okay, so that's not okay. 0, 0, 0 is no good. Well, who's got one that works? What do you got? Ooh, I bet you nobody else did that. I'm going to double check it. I think you're right, but 3 times a third makes 1. 3 times -1/3 makes -1. Add them together, I get 0. And then you had to get rid of this 3, so you times it by 0. Very nice. That works. Is there other ways? Oh, yes. Who's got another way that works? 4, 5, negative what? Ooh, I bet you're the only person that did that. Anybody else find that one? Okay, let's check it. 1 times 4 is 4. 2 times 5 is 10. That makes a total of... Oh, did I just do it wrong? Okay, I'm going to try that. Oh, yeah. I got it compared with the 3. Sorry. 3 times 4 makes 12. 3 times 5 makes 15. And 15 and 12 makes 27. And then you made this -27. Genius. That worked. You know what we could do on the test to keep me from having to check everybody's vector? What if I said, I'm not telling you that one. Do you get how you could make it work? You'd have to just kind of guess and check for just the last number until you found it. Or you could set up an equation. All right. Do you get that there's a lot of vectors that would have worked? I don't want to just keep going through vectors that would have worked, but I think you get the idea. You want the dot products to be 0 to be perpendicular. Okay, what else do? We take this vector and this vector, and we say, what's the angle between them? There's a formula for that. We are not giving it to you. Hopefully you know it. I'll pause for a second and give that a try. Okay, let's see how you did on this. You should have known it was A dot B, magnitude B, cosine theta. And then that dot that is this times this, -1. That times that, -4, making a total of -5. And then -12, total of -17, right? And then this one, square root of 9, 4 to 14. And this one, square root of, save me some time. 21? 20 or 21? Thank you. And cosine theta. And at the end, you divide both sides by root 14 and root 21. And this is a really important part. If you don't know this about your calculator, a lot of people put this in the calculator without parentheses here, and the calculator thinks you mean, so you're saying -17 divided by root 14, and then I'll do that first, and then I'll times by square root of 21. Do you get how the calculator might think that? Because the order of operations says that divide and multiply, you just do them from left to right. And so it would think that that's what you meant, and then times that. So you want parentheses here. So if you haven't already checked this right now, do your inverse cosine, try it with the parentheses there. You might get a different answer than you got the first time. All right? Who used parentheses? Would you tell me, HM, what you got? 172 point what? Thank you. Raise your hand if you got the same thing. Okay, awesome. And if you didn't, but you had eerily similar numbers, maybe it's because you didn't have the parentheses right. Okay, so those vectors are very much open. It's like almost 180 degrees, so they must be kind of like, whoa, almost all the way apart. Okay, so then, what about colliding vectors? I said I would take yesterday as a day off of those. Now we should go back to it. And let's see if you know how to make two vectors, well, not necessarily make them collide, but find out if they do collide, and if so, where. All right, this one. Leave yourself plenty of room on this one. You need a lot of room for like showing work. So maybe you zoom in so you're like not taking up as much room. 4, 2, 7 plus, we're going to use t for this one, -3, 0, -4. That one and this one are either going to intersect, or they're going to collide, or both. What's the difference? If you're colliding, you're at the same place at the same time. If you're intersecting, it just means you were at the same place, but you were there at different times. Pause for a second. Well, you see if those two vectors will intersect or collide, or colliding means intersect and being there at the same time. Pausing. These take a long time, so even though the kids are still working right now, I'm going to write out the equations so that we don't have to make you sit for too long and watch me do the same thing you just did. Of course, 0t just disappears. All right. Z is 7 plus or minus, 4t. And this one I'm going to do in green. All right. I'll pause while I set these up. Okay. So that one is the key one because it's awesome because it's only got one variable, which was awesome. So then I hope you noticed that one. And then when you solved it, did you get lambda equals 0? Raise your hand if you had. Lambda equals 0. Awesome. Now once you know that, you can go put that into either one of the equations and save me some time. Once I put in lambda equals 0 here, what did t come out to? T was 1. So we got two answers. Lambda is 0 and t is 1. Right off the bat, I know they're not going to collide. But what are they going to do? They're going to intersect. Watch. Watch. I know it's almost done, but watch. If I put this as a 0, do you get that all cancels and the point it's at is 1, 2, 3. If I put in the other one, t equals 1, it has to go in here. And when you actually multiply this all out, it ends up also at the point 1, 2, 3. That means they were at the same place, 1, 2, 3, but at different times. That means they intersect, but did not collide. All right. That's all the review I have time to do with you. Be ready for the test tomorrow. Have a great day.